The main manufacturing requirement for most sheet metal applications is good formability. This is the sheet metal's ability to deform into intricate shapes without defects in the finished part. In all sheet metal forming operations, one or more types of deformation are involved, including bending, stretching, and/or drawing. Part shape largely determines the relative severity of the sheet metal's formability, especially where drawing and stretching occur. But other factors also influence formability. Those include the ductility of the metal, the die design, the stamping press, press speed, lubrication, the sheet metal feeding mechanisms, and monitoring systems and controls which safeguard and synchronize the operation. Because of these various factors, formability differs from one part or operation to the next. Basic die operations include cutting, bending, forming, drawing, and squeezing. The two most common types of dies, however, are cutting dies and forming dies. Cutting, which includes shearing, blanking, hole punching, and trimming, is the most common press-working operation using dies. Shearing is a process by which large sheets of material are cut into smaller sections. These pieces are generally used in later operations. Blanking is a form of shearing that cuts sheet metal stock around the complete perimeter of a shape to form a workpiece blank. Reference to a blank in stamping usually implies the need to perform subsequent operations to the workpiece. Punching is the cutting of a slug from the sheet metal stock to produce a hole. Hole punching, as well as other forms of die cutting, requires specific clearance between the punch and the die. Proper clearance is a function of the type, thickness, and temper of the workpiece material. During punching, the stock is stressed between the cutting edges of the punch and the die. As the punch penetrates the material, stresses build up until fracture occurs. Close inspection of a die-cut edge of sheet metal stock reveals a burnished edge where the punch penetrated the stock, followed by a rough edge where fracture occurred. Mild steel generally separates when approximately 1/3 of the stock thickness has been penetrated. However, when harder materials are die-cut, penetration by the punch may be less than 1/3 the material thickness, and softer materials may require almost full punch penetration before fracture occurs. After a part has been formed, a trimming die is utilized to remove the excess scrap metal from the workpiece. Forming is a broad term for metalworking processes in which the shape of a punch and die is reproduced directly in the metal. Some common forming operations done with press-mounted dies include drawing, bending, flanging, and hemming. Drawing shapes a flat pre-cut metal blank by forcing it into a die cavity with a punch without excessive wrinkling, thinning, or fracturing of the metal. Various complex forms may be produced by drawing. Drawn parts may vary in size from small parts up to aircraft and automotive parts large enough to require mechanical handling equipment. For properly draw-formed parts, the force exerted by the punch must be great enough to draw the metal over the edge of the die opening and into the die. Additionally, the drawn metal must have a combination of strength and ductility to avoid rupture in the critical area where the metal conforms from the punch face to the punch sides. Compressive forces on the metal in the area beyond the die's edge will cause the metal to buckle. If this metal were pulled into the die, buckling would increase until the metal ruptured. To prevent buckling, the blank must be held tightly by a blank holder. On most forming presses, the blank holder is an outer ring through which the inner ram or punch passes. The blank holder holds the workpiece against the draw die to control metal flow as the punch forms the shape. In practice, the blank holder must exert less pressure against the blank than the punch, so metal can flow into the die, yet it must exert enough pressure to prevent wrinkling. Factors determining necessary blank holder pressure vary from part to part, but include the severity of the draw reduction, metal properties and thickness, die lubrication, and other factors. Bending is performed on sheet metal to gain rigidity and to produce a part of desired shape. Bending is usually done to make structural stampings, such as brackets, braces, and supports. Flanging is a forming operation similar to bending, except that the flanged edge is shorter and narrower compared to the overall part size. A flange can be bent down along a straight or curved line and is used for appearance, rigidity, edge strengthening, removing a sheared edge, and to provide an accurately positioned fastening surface. In sheet metal forming, hemming is utilized primarily to provide a smooth, rounded finished edge and to attach sheet metal parts together. There are 4 basic types of hems. Those include the flat hem, which can be used with materials having high ductility, the teardrop hem, which is used on materials lacking the ductility required to form the flattened hem without cracking, the open hem, and the rope hem, which are used to join sheet metal parts together.